Hi then folks, so this it will be the last main video for this academic year, and this just finishes off some of the work that we were doing in class last week using our new reciprocal trig functions and trig identities, and will enable you to look at these sort of questions here 2 to 5 of the new trig identities worksheet. In fact, I'm not really massively going to show you trig identities in this video. I will do as an alternative method, but I have a perhaps preferred method that I want to do. This question has told us that cos theta is equal to 3/5, where theta is an acute angle, and wants you to find sine theta, and so on. Now, we all have one of these, and we're not going to use them. It's not a method that the exam board will be wanting to see. Any old idiot can type in inverse cos of 3/5 and get the angle, and then just type it in to get sine. That's not what we want to do. So we're going to move the calculator away. If I need it for a little bit of simple number crunching, I might do in a moment. But we don't want to find the angle. We don't need to. And in particular, although this is a pure topic at the moment, you will find very similar things in mechanics that I will do with you when we start talking about particles on slopes. Because if I'm going to do this, actually, I will draw it like it is a slope. Because let's just think about SOHCAHTOA. We have here an angle, right angle triangle with an angle of theta degrees. A particle could be on this slope, in fact, if it was a mechanics question. Now we're told that cos of theta is 3/5. Now that's going to be the adjacent side over the hypotenuse side. Adjacent over hypotenuse is the ratio for cos of the angle. If I want to do sine theta, then we are going to just be thinking that sine theta is opposite over hypotenuse. So I need to know the opposite side. So it's a quick bit of Pythagoras here to work out the missing side. 5 squared take away 3 squared and square root it. Of course, to make life even more straightforward, it was a Pythagorean triangle that I'd given you. So it's a 3, 4, 5 triangle. So sine theta is equal to opposite over hypotenuse, so 4/5. Done. Second one, cosec theta. Well, I know that's 1 over sine theta, so that's going to be 1 over 4/5, so it's going to be equal to 5/4. The last one I've asked you to do is cot theta. Now that is there's multiple ways I could think about this, but the most straightforward perhaps is it's 1 over tan theta. Well, tan theta is TOA, opposite over adjacent, so 4/3. So cot then is going to be 3/4, the reciprocal of it. And that is it to a certain extent, but I have slightly ignored this information here that theta is acute. Now that won't change any of my answers, but I will redo this question shortly and tell you that theta is going to be an obtuse angle, so one between 90 and 180 degrees, and it will slightly change my answers. The reason why? Well, let's just have a think about sketching out our sine, cos and tan graphs. And I like to do this because I think you need to be good at your graphs and you need to be able to just sort of very quickly sketch them out. So that's what I'm just doing, and I'll keep referring to these ones in a moment. So I'm going up in my quarters here. So the sine graph looks like that, of course. The cos graph starts at 1, goes down to 0. So there's our cos graph. And of course I've been a little bit lazy, let's be neat. We need to label all my axes. And I perhaps need to write 90, 180, 270 and 360. Tan graph is asymptotic at 90 and 270, so I would do that first, and then that helps me to draw in the graph. Now, I said in this question that theta was an acute angle. So that's one between 0 and 90. Now if we look, this is where theta will somewhere between 0 and 90. And at any point on here, sine graph is positive. On the cos graph between 0 and 90, it is also positive. And between 0 and 90 on tan graph, it is also positive. So we're looking down here at the first quadrant, and we can see that we have some positive angles. Now I suggest now that I can change the question and make theta an obtuse angle, so one between 90 and 180. Now if I was to do that, this question would be entirely wrong, because actually if I look between 90 and 180, when cos is an obtuse angle, it would be a negative angle. So we'll just have to think in a moment as to how I'm going to change it and how it's going to affect things. What I want to think about though is just here there was a slightly different method that you'll see in some textbooks and videos. Now we were given a ratio for cos and we were asked to then find sine. Well, we could have used this. Sine squared theta plus cos squared theta is equal to 1. I'm trying to find sine, so I don't know what sine squared is, but cos squared I do know, because cos of theta is 3/5. So actually cos squared is 3/5 all squared. Now of course, now I've got to sort this out. It doesn't matter whether this ratio had been positive or negative. By the time I squared it, I would have 9 over 25. And I want to find out what sine is, so I've just got a little equation to solve, so let's just play around with this. I'll move the 9/25 over and take it away from 1. And of course, actually, if I write the 1 as 25 over 25 and take away 9 over 25, what do you get? Well, you get conveniently, in this case, 16 over 25. Therefore, if I want to find out what sine theta is, it's going to be the square root of 16 over 25. So that means that sine theta is equal to 4/5. But of course, when you do square rooting, is it plus or minus the square root? And that is when we have to think about our graphs here and what type of angle we had. So in this question, it was always an acute angle, which is why cos of 0 to 90 is a positive thing. So if I look up at my sine graph, then it means that between 0 to 90, I'd get a positive answer, not a negative one. So it was the positive square root that I needed. Using this rule, it perhaps highlights you the fact you have to think about when you're square rooting, is it plus or is it minus? So there is a little bit of perhaps an issue there to solve. So this is really important to look at the size of the angle. So I'm just going to redo this question. Crikey, too many videos. I've got to the end of the book, so let's just use a less exciting one. I know some of you have noticed the little Haribo images down there the whole time. This time, given that cos theta is minus 3/5, where theta is obtuse. Now we're looking back before just now, so I've given you a negative ratio, and I can see on the graph here that between 90 and 180 cos is negative. Now actually for me, the method I like to do is to do with ratios, and I would always draw this right angle triangle the same as I had before. But I tend to ignore the negative when I do this. Now cos is adjacent over hypotenuse, and a bit of Pythagoras will give me that answer is 4. So sine theta is opposite over hypotenuse, 4 over 5. What I just need to do is look at my graph and go, is it going to be positive or is it negative? So obtuse is 90 to 180, so it will be positive. So I'm finished, I've done the question, it is correct. Now, could run the risk of getting it correct by fluke to a certain extent, because you're probably going to put a positive answer down, because I've ignored the negative here, just done the ratios, because with the symmetry of the graph, lots of things stay the same. If I was then going to work out what cosec theta is, then that's going to be 1 over sine theta. Now, sine theta is 4/5. That means that cosec is going to be 4/5. But I was asking you to do cot theta. That's going to be 1 over tan theta. So tan theta is opposite over adjacent, so 4/3. But is it positive or is it negative? And that's what you need to always just think about before you rush on. Is it positive or negative ratios? So that's why I look at my graph. So we just slide down and look at the tan graph. Now between 90 and 180, so there's my 90, there's my 180, tan is below the axes. So for obtuse angles, tan is negative. So very important then that I make tan to be negative 4/3, otherwise it would be incorrect. Therefore my cot theta, as it's reciprocal, will be -3/4. Keep the negative at the top. We're not talking about gradients of tangents or normals, we're just doing reciprocals here. Obviously that question, if I'd used the identity cos squared theta plus sine squared theta equals 1, then actually I would have had -3/5 squared plus sine squared theta equals 1. That would have been my 9/25. So the method would have been the same as we had just now in the end, but when you did the square root, you would have had to have considered the graphs. So something that people don't always find totally sort of straightforward. I like to just ignore the negative if I have a triangle, and I just draw it as an acute angle and get the ratios, and then I'm sorted with the ratios, and then I just think about my graphs and work out whether the ratio should be positive or negative. You will see some textbooks and videos where they would just use the identities, and I could have used the identities that had 1 plus cot squared is cosec squared and so on to work these out. But I like doing ratios. I find it relatively quick. I just need to think about my negative values. So that will give you a chance to have a look at these questions here. And you can see in some of the questions, you've got a negative ratio. Cot theta is -√3. Well, that might make life a little bit easier if you just said tan theta is -1/√3, and then you can draw your triangle. Tan is opposite over adjacent, so 1/√3. Do a bit of Pythagoras to get your hypotenuse, and then you're away. And you just have to think about if it's an angle between 90 and 180, obtuse again, whether you're positive or negative tan. So there's a few here to look at. You might want to ignore question 2 for the time being. Think about 3, 4, and 5. As I said, I'll check emails hopefully weekly during the holidays. So if you've got specific questions that you want some help with, then you can just ask, and hopefully I can help you out and send you a little audio message. Okay, bye-bye.